In this video, we're talking about a unit of concentration called molarity. The symbol for molarity is a capital M. So let's define it for you. It's a very important unit of concentration. We use it a lot in chemistry, probably more than any other unit that you'll see. The definition of molarity is moles of solute divided by liters of solution, or moles over liters. And it's really important to remember moles of what? Of solute. That's what's dissolved in the solution. And liters of solution, not just the solvent, but the whole solution. Sometimes that matters. In symbols, a lot of times you write it like this. M stands for molarity is equal to N over V, where N is moles of the solute and V is liters of solution. So you should memorize the definition. It's really helps to know the definition of molarity. Now, when you're dealing with molarity, there's three variables in the definition: molarity, moles, and volume of solution. And there are different times when you'll be solving for any of the three. So these are just the three forms of that one equation where I've rearranged it to solve for each of the three variables. If you want to find the molarity, you know the moles of the solute, or you can find them, and you know the liters of solution, just moles over liters. If you want to find the moles of the solute, you just take the molarity, multiply it times the volume. Now here you make sure the volume's in liters. If you want to find what volume of solution you have in liters, you just take the moles divided by the molarity. Now let's do an example. Let's say you dissolve 11.4 grams of sodium hydroxide in water. Enough water so that you have a total of 1,425 milliliters of solution. What's the molarity of the sodium hydroxide? Well, before I do this, there's some notation here that you need to be familiar with. When you put the formula for a compound in brackets, it stands for the molarity of the stuff in the brackets. So we would say the molarity of sodium hydroxide is how we would read this on the left here. But going back to the definition, it's moles of solute over liters of solution. What's the solute? Well, it's what's being dissolved, in this case the sodium hydroxide. So moles of sodium hydroxide on top, liters of solution on bottom. So we need two numbers. Once we get them, moles of sodium hydroxide, liters of solution, plug them in here and get our answer. Moles of sodium hydroxide, we know grams, and remember, whenever you have grams of something, to find the moles, always divide by the molar mass. So the grams of sodium hydroxide is 11.4. The molar mass is 39.667 grams per mole. And remember, I got this number here, the 39.667, by looking on the periodic table, finding the molar mass of sodium, to it adding the molar mass of oxygen, and then the molar mass of hydrogen. So when I do the division, units grams cancel, I get moles. I get about 0.287 moles of sodium hydroxide. That goes on the top. That goes right here. Liters of solution, well, here's the thing. We convert in chemistry so often between milliliters and liters that if I have milliliters, I know to make that into liters, I just move the decimal 3 to the left, or divide by 1,000, same thing. So we have 1.425 liters of solution. We divide the two. We find that the concentration, we would say the concentration of the molarity of sodium hydroxide is equal to 0.202 molar. That's how we say the M, molar, meaning moles per liter. Moles of solute per liters of solution. So we know that for every 1 liter of this solution, we have 0.202 moles of sodium hydroxide dissolved in it.